Oh, what a mess.
This is Neil Schneider from Meant to Be Seen. Welcome back to my messy basement. We've got a great show planned for you today. I'm really excited because, we're in a high holiday season. This is the time to really get the word out about virtual reality and immersive technology. Master Yoda, may I ask you a question?
Ready you are for an advanced lightsaber attempt.
Uh-oh. Oh, okay. So today we've got a great interview with Lochlainn Wilson. He's the CTO for FOVE. So FOVE has this great FOVE has this great head-mounted display which features eye tracking. We'll be back with more right after this. Welcome back to the basement. To my immediate left is Lochlainn Wilson, Chief Technology Officer for FOVE. Welcome to the program, Lochlainn.
Hi, Neil. Yeah. So thanks for having me. I'm looking forward to answering some questions and having a good bit of a chat about where we are and where we're going. So thanks for inviting me.
First big question for you. Do you prefer to be called Lochlainn or do you prefer to be called Loki? Because all this time I've been calling you Lochlainn, and then I was speaking with your colleague Jim, and he's like, "Oh, you call him Lochlainn? We always call him Loki." And I'm like, "What the hey? What do I call you?"
So everyone in the office calls me Loki because it's easier. I have no idea why. It's like my old gamer nickname from when I was a kid, and it just stayed around. So
it's stuck. So it's a little bit of a curse there, isn't it?
Well, I was always everyone would just call me Lockie, the shortened version of Lochlainn in Australia. So it just eventually became easier to spell, I guess.
So let's talk a little bit about yourself. I mean, you're originally from Australia, I take it. What part?
Yep. So I'm from Brisbane. So actually, FOVE started in the hardware sense in a hackerspace in Brisbane. So hats off to you guys. It was fun. But yeah. So I was born in Brisbane. I moved up to the Sunshine Coast when I was a kid. Lived up in the mountains for a while. Then came back to Brisbane for the end of primary school and high school and all of that kind of stuff, and stayed in Brisbane basically until I moved to Japan. And then I've been back and forth between Japan and Brisbane since 2011. No, 2008, sorry, was when I first came to Japan. That was on exchange and bounced around. And now I live in Japan full time.
Yeah, you're a well-traveled individual. So you're in Tokyo now, I take it, yes?
Yep.
So what's that like?
Well, it's getting cold now, which is good. It just snowed a couple of days ago for the first time in 50 years in November. So yeah, it's
lucky you.
Interesting. Yeah, since the cold polar winds have been pushed off the Arctic, that came down here. So, well, not really. They hit Siberia, and we're getting a tiny bit of it. But yeah.
So let me first congratulate you and your work with FOVE, because the first time we met was a few years ago at SIGGRAPH.
Yes,
and I remember,
I
think it's been SIGGRAPH, it's been a few years already. And I remember you were showing an early prototype. It was, I may have a picture of it still. I'm going to probably find that picture. And it was literally being held together by a glue gun. And I remember you were showing some colleagues in your hotel room and the whole thing. And you've really, as a company, you've really progressed. So why don't we talk about FOVE? How did you guys get started?
Well, the start was probably one of the most interesting things that happened to us. So, of course. So how we started was just from pretty much an idle conversation. Yuka, the co-founder CEO, and myself were sitting down in Tokyo over ramen, just talking about sort of future projects and life as it was at the time. And so Yuka was upset at the time because one of her pet projects had been kind of put on the chopping block due to budget cuts in Sony. And so she was talking about things that she wanted to do in the future instead, how would I describe it? She was curious about doing avatar interaction, using sort of emotional cues from a player, such as eye contact and facial recognition and things like this. And at the time, so this was a long time ago, the technology to do that wasn't quite there yet. Our processing speed on mobile systems were probably a little bit lagging behind, and the methods that we have today for like really rapid image processing and neural network stuff just wasn't right there. So at the time, I said, that's probably really difficult to do on handheld devices or even on a computer. It would like shrink the market too much. But there's an interesting new market coming up, which is VR, and it would be really cool to do this in VR. So this was actually before Oculus sort of came to the stage and really blew VR like up into the air. But back then, like I already had my eye on it, and I was like, this is a cool area that's becoming so technically feasible. And it's also so important to have like the subtle aspects of like, well, to try and break the uncanny barrier is such a huge problem in VR, and have technology such as eye tracking allowing you to interact more naturally with AI or characters or other people is just, for me, it was a no-brainer at the time. I'm like, this would be really cool to do, and it's something that no one's really done or explored before. And so that was very interesting to me, and it was also interesting to her because it was in line with what she wanted to do with, you know, it was like her idea of revolutionizing character interaction at the time. And so we started to make this prototype, and as we showed it to more and more people, they're like, hey, this is cool, you guys should make it. Like, I want one, you should sell it. And it kind of snowballed from there until she found funding in Tokyo from I think in Japan they call them a Kojin Toshika, which is like an individual VC or private VC. I don't know what the term is in America.
Is it an angel investor? Is that the idea?
That's
or?
the one.
Okay.
Yeah, it's an angel investor. So we got an angel investment, and from there we rebased to Tokyo, and we went through a number of things. We went through a Microsoft Accelerator program in the UK. We attended Rothenberg Accelerator in Silicon Valley. Now we're actually here in a kind of startup-y base camp, except we own like half of the available space in here. It's kind of crazy. So we've bounced around like different accelerators and incubators for a while, and the team expanded from 2, 3, 4, now 30. So
wow.
Yeah, it's pretty cool.
So why don't you hold up the FOVE? I mean, we've been talking about it, but why don't we? Okay, so there you go, and turn it around. So what we see behind the curtain there. Okay. All right. Okay, good stuff. So let's tell us about the FOVE. What makes this head-mounted display so unique and so special, other than the fact that it's yours?
Well, yeah, it's my pet, so I really like it. But other than that, the main special feature is, of course, eye tracking. So we're the first, like, commercially accessible or privately accessible eye tracking head mount display for VR. So we're not just doing like an eye tracking system that doesn't work really well for VR, where we built our technology to pretty much the same standards as Oculus and HTC. I mean, we're not quite at the CV1 or Vive level in some ways. In some ways, we're kind of above them. But like, for the most part, like, we're on par in the virtual reality sense. And we also have this really cool feature of eye tracking coming in.
So we have, I mean, we could talk about the specs a little bit. I mean, what can you tell us, Mr. CTO, of the specs of the FOVE?
Well, basically, the thing that stands out right now is our resolution. We're running a single panel, unfortunately, so the frame rate's a little bit lower. It's at 70 frames per second. But the resolution is 30% higher or 40% higher than HTC or CV1. So we're pushing more pixels, have less screen door, and it's like it fundamentally, it looks better. That said, we don't have the same kind of lens technology that Oculus or HTC have, where we are using Fresnel lenses. They're very, very nice lenses, but our field of view for some people feels a little limited. But that's mainly because we don't have any like mechanical adjustment yet, because we're a single screen solution.
But this is...
When we move to dual screen next time, we will be feature par with everyone else.
Okay, I got to know, what does that thing look like inside? All right. Well, you're going to have to explain it. You can't just show it.
Yeah, all right. So the stuff you're seeing right now is the green things are our circuit boards. So the one at the top is our motion tracking board. The one at the bottom is actually two boards because we were we're running on a rapid prototyping development cycle. One of them is our microprocessor and camera system, and the other one is our display driver. And so these were hot swappable during the design process as we were experimenting with things. But that's just more of a geek thing. The golden things you're seeing, they're the flex cables that hold our position tracking system. It's kind of loosely based off the Constellation style system, except we don't do any kind of synchronization. Our system, for the nerds out there who are really keen on motion tracking, is, I guess the term would be asynchronous. It does not require synchronization, and it can support theoretically an unlimited amount of devices, although I think we cap out at about 8 or 10.
I'm not sure I understand. Can you rewind a little bit? So what were you explaining about the synchronization?
Okay, so Oculus, when they pioneered in VR this tracking system, they blink each LED with an individual code that your image processing system uses to track what's called the correspondence of the point. So you've got a bunch of blinking lights in your camera feed, and each one of these blinking lights is synchronized with the camera, so it's pulsing out maybe an 8-bit or 12-bit code continuously. So every 12 frames or 8 frames or whatever it was, you can see or know what the ID of this pixel is at any time. And so you can use that to initialize your motion tracking system and follow it very precisely. So there's no chance that even once you've lost the system that you need to do an expensive recapture routine. Our system is a little bit more sort of sensor fusion based. We maintain an internal state of the system using our sensor information, and we fuse that very intelligently with what we're seeing on the screen. So we're basically doing a blind tracking system. Blind in the sense that it doesn't know the correspondences, and the tracking system is for example, it's a full sensor fusion system. And why that's kind of unique is it means that the system is a lot easier to scale. Like, for example, Oculus Touch took a while to come out. That's possibly due to synchronization issues and FCC kind of stuff, because they've got to have their own custom Bluetooth synchronization signal going with the camera to keep the camera clock in sync with the devices. And so our technology doesn't require any of this. It just, once it's found the headset, it just goes and it stays with it. Even if it loses the headset, it uses a combination of, dead reckoning and some fancy mathematics to make sure that it doesn't lose the headset at all. Or if it does, the cost of finding it again is trivial. So it's pretty interesting from the image processing perspective. We did some pretty cool research on that. It wasn't supposed to be one of our major bragging points, but our motion tracking technology is pretty cool. Even though we're using the same camera, for example, as OSVR, our system is fundamentally different, and I would think that it's technically on a different level.
So I'm going to see if I even understand this, because it's, it sounds a little bit rocket scientist-y here for me, but...
My bad.
Okay, no, nothing to be bad here. So you're using an external infrared camera, yes?
Yep, that's right.
And then now when it comes to synchronization, I take it what you described is with the Oculus Rift is they've got the infrared outputs, but they're each emitting little codes that that's being detected. So that's how they know
with OSVR.
The precise positional tracking. So in your scenario, you're using a similar infrared camera, in this case the OSVR camera, but what is the head-mounted display emitting that the camera knows where things are at?
Just light. We can individually pulse the LEDs on our system. We just don't. It's not necessary. So we're sending out just continuous light. If we lose the headset, there is a chance it will send out a pulse at a slower rate, a slower frequency to find it. But that's a very big if there. That's like for the initialization or something like this. Once our system is initialized to start with, the sensors are good enough to keep it tracked forever.
Okay. And now this isn't designed for the head-mounted display. Is this tracking, easily transferable to controller devices and other? So that's
it is.
Okay. And how does and what about now? I know there was a big deal made about FOVE working with Lighthouse. Is that still even necessary? Like, what's the plan there?
Well, it's not strictly necessary for us in a technical sense. However, Lighthouse as a tracking solution still has significant advantages over optical, and the accuracy that's capable of being it's the standard from Lighthouse is extremely high. And if you're wanting to do a room scale experience, it's certainly easier than having multiple wired cameras around, because the Lighthouse units themselves, they're just dumb. They just sit there blinking. you don't need to connect them to anything really. They can just sit there spinning by themselves and they're happy. Whereas if you're using an optical solution, you're going to have to connect the cameras to a computer, which is going to have to do the image processing. So there's a fundamental limit on how many cameras you can use. And then there's limitations on how far away you can place them by signal degradation and things like this. So for me, for large scale, Lighthouse is the way to go. For small scale, we have the choice. So that remains to be seen where we'll go. Yeah.
Okay, good stuff. So
because the advantage with our system here is every peripheral for Lighthouse is smart. Our peripherals can be dumb, whereas the camera can be smart. So that's basically how we approached it. We wanted to not have too much work done on any of the peripherals. We'll throw that work down to the computer, and we've done that in a way that's optimized to the point where it's no additional cost over the traditional systems, yet significant advantages in the kind of electronics or signaling that you need. So it's just something we randomly developed. It was kind of serendipitous, but it's kind of cool.
Okay, perfect. This is just a developer's kit though, right? This isn't a final product. This is the proof of concept to get to the next stage, yes?
I still aim high.
Yes.
I aim to make it consumer. I literally, when I started this project, you start with the end in mind, and my end goal is to have a consumer-ready piece of technology. And so I got maybe 90% there with our team. It's pretty good. There's a couple of things that we just weren't able to do. We couldn't acquire dual screen technology in time. We have access to that kind of stuff now. I couldn't acquire Lighthouse in time. We have access to that now. So basically, we had to reinvent the wheel a couple too many times. But the end result is we still have a very usable product that, for a developer's kit, is extremely high end.
It sounds very positive, and it's very good, of course, that it's out there.
Yes.
So, ever since the very beginning, since the foundation of FOVE, or the founding of FOVE, I should say, eye tracking. I mean, you've dropped those words a couple times already, so let's talk about it. What is eye tracking? Why is it so important?
Well, there are so many layers to this. So one of them that everyone talks about is foveated rendering. So as screen resolution goes up, processing power requirements go up kind of polynomially, which is a bad thing. You don't want that. Eye tracking is a way of adding a significant mitigating factor to the computational requirements. If you only render what someone's looking at in full detail and kind of gloss over the other details, the user doesn't notice, and the GPU certainly does. So you can run, even now with our resolution, you can get savings of 2 to 3 times just by doing proper foveation. And so our GPUs are thankful for that. You can do a lot more interesting things. I've got a demo that does full depth of field in VR aiming at where you're looking at, so it's not an unnatural depth of field that's fixed at a point or fixed to your gaze. It gaze as in the VR current industry definition, which appears to be where you're a point going out from your nose. For us, gaze is actually where you're looking. So yeah, it's a little bit confusing when we're talking internally.
Maybe we could clarify a bit for people that don't understand, possibly myself included. So when we're talking about what did you call it?
Foveated rendering?
No. Foveated rendering, I understand. Okay, so you only have the processing power where you're effectively looking. So you're not wasting processing power on things that you never actually see. But the other one, depth of field, that's the one.
Yes.
So the depth of field, I take it, when we look around in life, the world is actually effectively blurred. It only focuses on exactly where we're looking. So usually, so I take it this is a technology that's used to kind of simulate what we're experiencing in life. That's
correct. So a very big example of this is if you're looking at a user interface in front of you, and behind it, it's a kind of transparent, imagine a transparent user interface, and there's text on the wall behind you as well. So in real life, when you look at the user interface in front of your eyes, the text will be blurred to the point where our brain no longer processes it and basically ignores it. In current VR, if you have text in the foreground and text in the background, you read the text in the foreground and also 2 texts split in the background. And it's annoying and kind of unnatural, and it causes all kinds of depth fighting issues. You'll try and focus on one and then the other, and your brain doesn't really like this situation. And for me, I find it very uncomfortable. So another thing that seems to get caused a lot is by having too much detail in the peripheral vision, you can cause motion sickness because our periphery is very, very sensitive to fine detail that's moving. Not so much fine detail itself, but like if you have lots of sharp points that are moving, our periphery detects that very, very strongly. However, if it's more blurred, we have a softer response and things feel more natural and VR becomes less demanding on our sensory system.
Mm-hmm. So you used the word, and I think this ties in, you used the word uncanny barrier. Yes. Actually, there's two words, I'm sorry, uncanny barrier. You just kind of flew across the screen when you said that. So can you elaborate what you meant by that? What is it? Why is it important?
So the uncanny barrier is another massive thing that we're looking at slowly tackling in VR, and that is basically how we respond emotionally or at a sort of instinctual level to the content that's being presented to us. So, for example, if you look at a person who's not quite rendered right, the skin shade is just a little bit off, they'll feel really creepy and plastic and weird, and then when they move in a kind of natural way, you're like, no, this is wrong. And you kind of get a disgusted reaction because like you're seeing something that should not like happen. You're seeing like a plastic doll move like a human or something like this. And at a fundamental instinctual level, our brain's saying, no, this is wrong and this shouldn't be happening. And we get that kind of response. The same thing happens for me with virtual reality characters at this time. They either stare at you really creepily or they're completely oblivious to what you're doing and where you're looking, or at least they don't act anywhere near close to naturally. And one thing that's going to help significantly with that is eye tracking. So we know what you're looking at, know where you're looking at on the other character. The character can see what you're looking at and respond to that, and then maybe comment on what you're looking at. This kind of thing allows a whole new degree of subtlety. And for normal game development, it was probably not necessary to go to this level. But in VR, when you're really up close to the characters, you're literally within reach, like arm's reach of each other, and they're physically present to the same degree as a person would be, it's critically important that they start acting, with a sort of theory of mind, a sense of presence. They start like responding to you just as much as you would respond to them. And this kind of interplay is one of the things we're really interested in doing, or not necessarily doing, but enabling. So we would like developers to latch onto this and say like, hey, I've got these cool ideas for character interaction, and FOVE can make this happen. And yeah, so that kind of sort of segues into where we're heading in the future as well, where we're going to be doing full face recognition, not recognition, but tracking. So facial feature tracking and avatar projections in the next model.
So it would be kind of like if I'm playing, like an Elder Scrolls game, like Skyrim or something like that, and I'm walking around and the characters are looking at me directly, like if I'm talking to a character and they're gazing directly in my eyes, would that be a working example of this? A
working example, like gazing directly into your eyes, is what they do now, right? They just sit there staring like this.
Well, okay, yes. Maybe that's not the best example because that's just as creepy as them not behaving properly. But what would be a really good example?
Okay, when you look at a character, if you stare at them for a couple of moments, they then look away. That's a natural reaction. If you can get like an emotional sort of exchange of information in this as well, but if you play with the dwell time, like how long a character stares back into your eyes, you can really develop you can play with the emotion of the player. You could make this could be the difference between flirty or being aggressive or being shifty. For example, if you look at a character's eyes and the moment you look at them, they look away. Like, hang on, can I trust this character? What are they thinking? What are they doing? Like, there's these things that we can work with that you could otherwise not do. Like, there is no way currently to guarantee that when you are looking at the eye of a character that they know that and they can look away. But now using our FOVE technology, you can. So the moment you look at a character, they can be a bang and away and acting all shifty. Or you could walk up past the character and you could stare at them and then they stand up and grab out their sword and say, what are you looking at? You do all kinds of things. It's just you can bring out the personalities of characters in ways that you otherwise couldn't.
All right, good stuff. So let's talk a little bit about the platform. I mean, whenever a head-mounted display such as the FOVE is released, it's important that there's some basis for software support, be it your own software developer's kit or something else. So what do you have in existence? What do you have in the works?
We currently have our own compositing SDK with asynchronous time warp kind of features and various predictions and motion trackings. Everything works using our SDK. It's written in C++, and it's very easy for developers to link into. It's been based off of we looked at what everyone else got wrong in the past, and we've definitely made some improvements in our opinion. So, I mean, we've still, it's not perfect, it's a developer's kit, but we've definitely made a product that is in line with what everyone else is doing and how it's being used, and also we've tried to avoid some of the problems that have happened in the past. So it's a good structure there, and that's our core SDK, and so anyone using any game engine that they have the source code to can easily drop stuff in using our SDK. Better than that, we have Unity plugins, Unreal plugins for people who just want to hack and get going straight away. And we're working right now on finalizing Steam OpenVR support. So we'll be able to run any sitting experience controller-based VR content that currently exists.
So I'm wondering, when you support something like Steam VR, I think you're doing some work with OSVR as well, and maybe you can confirm. Does your foveated rendering work out of the box, or is additional coding required?
So we debated internally about how to approach this. Technically, right now, it's not feasible for it to work out of the box. And even if it became technically feasible to do this, there are sensitivities on the post-processing side of things. If we're playing with what people have tuned in without their without the consent of the developer, we decided this was a really bad idea. So for now, the answer is no. We're not going to do that out of the box. However, if you are supporting a multi-resolution shading system, such as what NVIDIA is doing right now, and you've already got everything configured for that, we could very easily control that, and it would be no significant issue. But we would still like to leave that in the hands of the developer as to whether they enable that or disable it for now. But as multi-resolution shading becomes more of the norm, we will see our foveation technology just simply be a drop-in.
All right. So you got this developer kit. I take it, can people buy it today? Is it readily available?
It's on the website now for pre-order. So if anyone's interested, please go grab it.
Of course, people are interested. Don't say if, they are. So what's it going for? How do they get it?
So our website is just getfove.com. Just go there, and there should be a pre-order button. Click on that, and then there should be a checkout somewhere.
Okay. All right. Good.
So
Good
just
stuff.
go there, take a look. We have some demo projects that are coming out on release. There's going to be a lot of stuff for people to just get started with. I'm not sure exactly what source code we're releasing right now, but there is going to at least be a Unity sandbox and an Unreal sandbox, and we may or may not release some of the source code for some of the demos that we've been doing in the past. That's not final, but there's definitely going to be collaborative stuff happening as well. So if some developers have some ideas on our forums, which we have, by the way, we're going to look at them and maybe help people get started. I've heard some pretty cool stuff about some people wanting to work with us on a project for people with paralysis or ALS, so inability to use their hands and arms properly. People could benefit from having our headset technology, enabling them to have experiences in virtual reality and even interact with their computer in a better way than previously possible. So just things like this. We're keen on collaborating with the community, getting people started, and sending them off in the right direction with our stuff.
We should actually, before we go, we should quickly talk about that. You're highlighting use cases that go well outside video games. I think the first thing people think about are video games. However, I would imagine there are equally exciting opportunities. This is one. Have other things crossed your desk?
Yeah. So one of the things that we worked on initially when we started was autism research. So we made a program for kind of training people with kind of severe form of autism to make eye contact and to evaluate this in a safe environment. So our technology can be used in many things, from ranging from autism research to optical stuff. We've been talking with the diplopia people. We can work about fixing lazy eye, for example, and training people to gaze correctly. We can correct for vision problems as well. So if your eyes are misaligned and you want to play VR right now, you can't. well, it's the same with the real world, it'll be separated, but we could correct their vision slowly in VR by sort of shifting the images that are appropriate for their eyes, for example. And there's people who are approaching us about this technology. There's people who are approaching us about using it in education, because you know where people are looking, you know where people are paying attention. You can look at how often they're blinking. Are they tired? Are they engaged? You know, you can tell all of these things. So it's super interesting from so many perspectives. There's a lot of R&D that can be done with this system. So that's another one. Like, I want researchers to buy this and try it. If they're into neuroscience that does anything with sensory information, they should probably get one. Yeah, there's a bunch of things. I mean, we've even had the military guys talking to us. But yeah.
Well, yeah, but you know, amazing things come out of the military that isn't necessarily military related. So
yeah. Oh, I know.
But even all the same, I mean, this is amazing because people could get the technology today, start benefiting from it today. Like, you know, if you want to use an example like Oculus, when the DK1 was out, you know, and you know, people were actively using it right away. And I could see, you know, as this is a new addition to the medium, I think a lot of people could really benefit from your technology today.
No, I think so as well. I'm really excited to see what people do with it. Like, we were kind of like at the point where we've like put a lot of work into this thing. We've been like nose to the grindstone for about 2 years now as a company, trying to get like everything made to this point. And we look outside right now, the ecosystem's bare. There's like no one other than the people we've engaged with have made anything for FOVE because it doesn't exist. It's not out there. What's going to happen when we throw this out? Like, everyone is really excited to see what comes out of the community and the world at large. So,
right. Well, yeah. Good stuff. So, congratulations on your continued success with this. I think you're going to go very far. And thanks for joining us in my basement.
No worries. Thanks for having me. Yeah, I've been pretty hard to catch, so but I appreciate your persistence.
No problem. All the best. So we will be back with more right after this. Thank you for visiting me in my messy basement. If you want to be a guest on the program, by all means, email neilsmessybasement@mtbs3d.com. I think Yoda has something to say here.
Its energy surrounds us and binds us.
Are you trying to steal the show? Master Yoda, may I ask you a question?
Yes, my Padawan. A question you may ask.
Is virtual reality going to sell really well this year?
Ask a question, you should. Answer I will. Yes or no.
Is virtual reality going to sell well this year?
The future is.
Let's try this again. I think he's dodging the question. Master Yoda, may I ask you a question?
A question you may ask.
Is virtual reality going to sell well this year?
Within yourself. There you will find the answer.
You know, he normally says yes or no, but he doesn't seem to want to answer this time. Okay, well, on that note, thank you so much. We'll talk again next week.